This video is going to show you how to use version 3.37 of Flux to determine an improved sampling scheme that will reduce the coefficient of variation of the flux estimates. So again, we'll open version 3.37. Go to the resume the save file. You currently have just one strata. All the data is in the single strata, so the optimization scheme is under list, and here you go look at breakdown by stratum and optimum sampling. I'll just show you what the results look like, and with just all the data pooled together, we'll see that there's no way to identify a better sampling scheme. It'll be once we break it into strata that we'll be able to see how we want to move the sampling around so that we can improve the load estimates. So if we look at this output, we say here's the breakdown by stratum. We can see the coefficient of variation is 0.179 for the load estimate. This is with method number 2. Method 6 would give us some other coefficient of variation, and the actual optimum sampling will be dependent on the method. But as I indicated before, as we do more stratifications, the methods approach each other in terms of their the estimated load, and also the coefficient of variation. If we look down here, the sample allocation presently and the optimum allocation, which is NE opt %, this table is going to show us how we might rearrange the sampling so that we can improve or reduce the coefficient of variation. In this case, there's just one strata, so NS is the number of values in a particular strata. It's all 111 are in the single strata. NE is the number that's also in the strata, but the NE % is the % of the total number that are in that strata. What's important here is you get the coefficient of variation, and then the optimum arrangement of the sampling is given here. And of course, because we only have one strata, there's no way to rearrange the values in any way. And so it's down here at the bottom. It tells you how rearrangement would improve the coefficient of variation, and we can see that it is not improved at all, because we have no way to rearrange the data among different flow schemes. So it goes from 0.179 to 0.179, which is exactly what we have up here. So now we'll go back, and I'll jump right up to 4 strata for this data set, and we'll see what happens in that case. Okay, so now we have the 4 strata. We'll look at the list. So now this is the arrangement that we have, and the coefficient of variations for method 2 for each one of these different ranges goes from 0.299 to 0.460. If we do a optimum arrangement of the data, we would have the estimate go for the coefficient of variation go from 0.14 to 0.117. The current allocation of sampling to the different strata, we have 4 strata, is 26, or I should put it in terms of percent, 23% in the less than 1/2 mean flow, And the less than, between that one and the 2 times the mean flow, we have 39%, almost 40%. The next one is 34%, and then the last one is 2.7%. The flux model goes through and determines where those samples would have been better placed within this scheme. So instead of the 26, 44, 38, 3, it tells us we should rearrange them in a different way. And the way in which they should be arranged is this way. So 5.8% of the values or samples should be from the very lowest flow instead of 23%. Almost 31% should be in the second strata instead of 39.6%. The next one should be more heavily weighted, 53.9% versus 38% originally. And the very highest flow range should be 9.5%, or 9.5% of the samples should be there instead of the 2.7%. So if you use that optimum scheme, the coefficient of variation goes from the original 0.140 to 0.117. That would be the predicted improvement in the coefficient of variation if we were to rearrange. Now that's just a prediction, but it's the best estimate based on the data that was collected for the site. Okay, so one does need to have data in order to be able to figure out how you're going to better design the scheme. But if you had a monitoring system in place for a period of time, probably a year, but maybe even a little less than that, you could actually put that into the flux model and have it do an analysis of the data and figure out, well, how might I adjust the sampling scheme to improve it in the future. And one could continually update the sampling scheme to improve the results just by going through a simple procedure that we just walked through. Now, it might be interesting to see what happens if I go with method 6 and see what happens here. Well, the coefficient of variation with the original sampling scheme was 0.142. If we go with the optimum sampling scheme, which is a bit different than the one that we had from method 2, we go from 0.142 to 0.114. With method 2, it went from 0.140 to 0.117. So there's not a lot of difference between them. There are some differences here, a few more sample points in the third stratum and fewer in this case in the very highest stratum, because we had 9% for the method 2. So things get arranged a little bit differently here. And I'm sure that if we tried some of the other methods, we would find other results. Okay, so that's how you determine the optimum sampling scheme, and that's what you should be reporting for your in your assignment 2. Now it would be good if you went through and determined what that optimum sampling scheme would be for each of the 3 data sets, the TSS versus flow data that was, or I should say the sample data that you have, 1984 to 2001, 2002 through 2006, and then 2007 through 2012. Because the sampling schemes are probably different between them, and so when you go through those, you could easily just determine what the optimum sampling is for each of those schemes, or for each one of those data sets.